and pre-processing. And pre-processing, there were issues to do with post-harvest handling and how to avoid contamination in that. And with freezing, we're looking at subjecting food to very low temperatures that will help in inactivating the microorganisms that are present in food that could be able to cause deterioration, but also things to do with the exposure to oxygen and also exposure to light. And we saw a number of things in there looking at the freezing cycle, things to do with the compression, expansion of the refrigerant, and also the evaporation and the heat exchange, and a number of things. So today we are going to interest ourselves with the last bit of the we are going to interest ourselves with the last bit of the module, which is going to be thermal processing this far. And we are saying that in thermal processing, really, we are trying to look at heat application where we are adding heat to the food, okay? And we are saying, why do we heat food? That is the whole reason as to why we heat. Not only do we want to soften the membranes of the food, but also we are trying as much as possible to eliminate the harmful bacteria and the viruses and all those other microorganisms, the parasites that are present that could cause foodborne illnesses. But also we are saying that this heat that we subject to the foods disrupts the cell membrane and also denatures essential proteins, rendering them inactive. Thus, we see that when you're heating food, careful consideration should be taken not to denature the membranes, but also try as much as possible to eliminate those microorganisms that would cause the foodborne illnesses. And we are saying, what does the heat do? We are saying heat can extend the quality. Okay, it can extend the quality through extending the shelf life of food. And we had looked at shelf life as the duration it takes for a food to go bad or a food to lose its original qualities, things to do with the sensory, the texture, and also the color qualities. So we are saying that when you heat food, you extend its sensory qualities. We had looked at drying, but it is not to be mistaken with food, with heating. When we're looking at drying, we're looking at eliminating water, okay, finding ways in which to remove water from the food. But with heating, we are subjecting the food to temperatures, and you will see that other foods could also be in liquid state, but could also be subjected to heat, and we extend their shelf lives. Things to do with milk and etc. So we are saying it will slow down spoilage of the food and deterioration that could be caused by those enzymes that are always present in food. And when these are broken down, we get the desirable qualities. But if they are not, these enzymes will be able to break down the qualities that we expect the food to have, things to do with the texture of the food, the color, and etc. So also we say that when you heat these foods, and for example, those tight, the foods with huge structures, things to do with the collagen fiber, the tissues in meat, we are saying once you eat them, this will improve the texture and the digestibility of some of these foods. Okay, such as cooking these beans will help them soften. Cooking the meat helps them soften, but also overheating could harden some of these foods and etc. We are saying also there is development of new flavors and aromas through reactions like caramelization, which we call browning in most cases. There are some people who prefer meat roasted because of that aroma it gives. The roasted meat gives a different aroma from the meat that is not roasted, and etc. Also, in product development, we are saying some specific cooking methods, forms of thermal processing, and these are used in achieving textures and flavors. Things to do with the baking of bread, the grilling of meat. So this will give you a different product compared to the product that you would get if you are done steaming, if you are done stewing, and etc. Okay, so what do we have to look at here in balancing the safety and the quality? Okay, we are saying it is a delicate balance. Well, I'm rushing a bit. I don't want our battery to catch us. This thing, I'm using a different thing here that could drain the battery very fast. We are saying balancing safety and quality. Okay, we are saying it is a delicate balance where we are saying higher heat kills more microbes, but can also have its negative impacts on food. We understand that when you're doing thermal processing, you're trying as much as possible possible to eliminate microorganisms. But we still do not want to lose the texture and the other things, the other sensory attributes of that food. So what happens if you heat the foods a lot? Well, you will denature the enzymes, but also you will kill the microbes that are present in food. But also things to do with the taste. When you apply a lot of heat to the food, this can alter the flavor compounds, potentially leading to those burn off flavors. You understand when you're even miles back, you can understand that, oh, that person is cooking beans and those beans are burnt because of that flavor that it will give off from a distance. And that flavor is not desirable if you're operating a food shop or a cookery, something like that. But also the texture. Overheating causes toughness in meats and mushiness in vegetables. This is what we are talking about. But also, if we are looking at an example such as fish, once you heat the fish a lot, the softening, no one wants to eat fish as if they're eating porridge because the fish is soft. Then we subject it to low temperatures, or we just let it simmer a bit or boil a bit or something like that. But also, under the nutrient considerations, we say that some nutrients, such as the vitamin C, are very heat sensitive. Okay, and this will be lost when you start the processing by subjecting the fruits to heat or the vegetables. So, while not a primary goal, heating can deactivate enzymes contributing to spoilage, e.g., fruit browning. However, excessive heat can destroy the beneficial enzymes too. That is why we tend to look at conservative methods of cooking when we are cooking some of these foods, such as the vegetables and etc. Okay. The product range, we are saying that thermal processing techniques are used for a bursary of food products, okay? But when we're looking at conservative cooking methods, that's where the steaming comes in, that we as much as possible want to kill those foods, we want to kill those food microbes, but we do not want to lose the vitamin C or the nutrient quality, because at the end of the day, we'll be only eating empty calories. So what do we do? Empty calories or fiber, I should say. But what do we do in this case? We try as much as possible to limit that heat to only amounts that will fail to denature or that will fail to make to evaporate our nutrients. But also, in an attempt, we tend as much as possible in the steaming method to try as much as possible to trap that steam so that it does not escape with our foods, but also cook these foods using only that vapor that is coming from a different food stuff. When we are talking about thermal processing, we are saying this encompasses many food products, and we are saying it aims at achieving various goals like safety, extended shelf life, and also the other desired qualities such as the caramelization of food. Okay, now this is where we talk about the liquid foods. You remember when we're talking about drying, but also now here in the heat treatment or thermal processing, we're looking at the liquid foods. Okay, liquid foods such as milk and milk products. And this is very essential for us to memorize or to remember, to understand. We are saying the milk and milk products through thermal processing, particularly the pasteurization method, and also the sterilization or the ultra heat treatment. We are saying this is crucial for ensuring the safety of milk and also milk products like the yogurts, the creams, and these methods help us in eliminating those harmful bacteria that cause foodborne illnesses. Okay. I don't expect you to say this method helps us. The word to use there, a scientific word could be AIDS. Okay, we don't expect anything to help us. Everything is supposed to work the way it's supposed to work. So when you're writing, never use the word aid, but well, I'm just presenting. That's why I can say this helps us, this helps us. But in most cases, it is aid or it does this because it doesn't have any other role that it performs. So we are saying juices and beverages. We are saying pasteurization is commonly used here for the fruits, soft drinks, and also those alcoholic beverages like wine. Okay, and this will help in extending the shelf life by inactivating those spoilage enzymes that are present, the yeasts and etc. that can cause fermentation or spoilage, depending on the desired quality of the manufacturer or the person making this product. All right. We are also saying that the soups and broths, depending on the desired shelf life, these products can undergo pasteurization. That is point to note that once you expose some of these foods to high treatment, or you expose these foods to a lot of heat, you will cause some qualities of this food to be some qualities that you desire from this food to be lost. Okay, so as much as possible, try to understand the particular or the desired qualities that you do not want to tamper with, and that is the type of heat treatment that you will use, as we will see in detail for the pasteurization or the sterilization. We are saying sterilized soups require refrigeration, like we saw, while the sterilized soups can be stored at room temperature. That is also key. And do you have a refrigerator or not? But if you don't have, then you will opt for the sterilized method. But if you have, then you will opt for the pasteurized method of heat treatment. Okay, for the fruits and vegetables, we are saying canned fruits and vegetables. Here we are looking at sterilization being the primary method of these canned goods and vegetables. And I think from our understanding, by now we understand that sterilization method helps in increasing the shelf life of a food more compared to the pasteurization method, I should say. And we are saying these canned fruits and vegetables, we are saying their primary heat treatment is the sterilization method, which ensures a long shelf life by eliminating microbes and also preventing of storage. We looked at also this sterilization when we were looking at packaging, looking at sterilizing those packages to prevent any introduction of microbes before you put in the food, but also sterilizing the foods themselves. So the frozen fruits and vegetables blanching a pre-treatment involving brief exposure to hot water or steam and used before freezing. I hope you remember this when we're looking at foods to put in a refrigerator or things to do to foods that are going to undergo refrigeration. And I'm saying what happens here, this blanching will help inactivate those enzymes that can cause browning, but also the loss of quality due to storage during storage. Okay, yeah. So exposing these foods to that heat for a short period cooling, we are saying this will help in inactivating the enzymes that can cause browning and also quality loss during storage. So the fruits and vegetables, the dried fruits and vegetables, dehydration often combined with pre-treatment like the blanching, which we saw, removes water content and also it inhibits microbial growth. So we would ask you on the what is the best method of heat treatment for the canned goods, the frozen fruits and vegetables, but also for the dried fruits and vegetables. Okay, where we are looking at dehydration, often combined with the preheat treatment, and also the blanching, which helps us in removing the water content, inhibiting the microbial growth since now the water activity has been reduced, and also the moisture content. This will significantly help us in increasing the shelf life of food. For the meats and poultry, the canned meats, like we said, in most cases when we are talking about canned, don't confuse it a lot, but it is the same as closely linked with the tinning. Okay, yeah. So for the canned meats, we are saying sterilization is used for canned meats like the corned beef and the luncheon meat, ensuring the increase in the shelf life or extending their shelf life, I should say. For the cooked hams and sausages, here we are looking at a thermal processing that involves our normal cooking, things to do with baking or smoking, and these are all used to achieve desired doneness or desired qualities, issues with the texture, the flavor, while also reducing the microbial population. Okay, so the pre-cooked poultry products, some poultry products are pre-cooked using thermal processing methods like roasting, boiling to extend the shelf life and improve convenience. For example, I could talk of I've seen people exposing meat. Actually, it's not meat; it's chicken. They cook the chicken a bit, but they don't bring it to doneness, or they don't make it overcooked. So that when you come, they just get it, put it in the cooking oil, fry it a bit, then they give to individuals. And that is the type of meat that we usually find on the roadside. Okay, for the grains, we are saying the bread and also those other baked goods. We when we apply heat to them in this thermal cooking or the thermal heat treatment, we are trying as much as possible to inactivate those enzymes that could cause or flavors or the browning reactions. But also, we are saying that when we heat these foods, uh, it creates those desired textures and also the browning that comes with the breads, and also it gives us those flavors. But also, in a way, it will help us. It will help us in activating those enzymes. For the pasta, all the rice and things to do in the rear and all those other things, the macaroni, etc., spaghetti, we are saying drying is a primary preservation method for pasta. Some pasta varieties may undergo pre-drying using thermal processes to facilitate further drying or removal of moisture from them. Well, for the other products such as ready-to-eat meat, these often involve thermal processing like minimal cooking, minimal sterilization, and packaging to ensure that their extended shelf life is a quality that they do have, because these are ready-to-eat meals. Okay, and we are saying for the nut butter, we tend to do the roasting using the roasting can be used for these nuts before processing them into nut butter. But also, this will help us in enhancing the flavor and the texture and also reducing the microbial load. Well, we understand that most of these things to do with these products, what is keen to understand are the desired qualities and what does heat do to them. What does heat do to them and what does heat do for them once you expose these foods to heat, and uh, what are those qualities that they will retain or that they will pick up from the exposure to heat. All right, so now let's look at reaction kinetics, and we are saying this is the actually the way. Okay, so this is the explanation, or this is the science behind how heat affects these microbes. For example, the spores, dormant stages of some bacteria are usually heat resistant. So even if you apply heat, you will find that some of these microbes, as we will see, would not be denatured or would not be deactivated. Okay, yeah. So here we will look at other ways of using heat or we will look at other ways other than heat to help us in destroying these microbes. Okay, so temperature dependence. We are saying temperature plays a crucial role in effectiveness of thermal processing, and we are saying that higher temperatures require shorter processing times to achieve the same level of microbial kill. Okay, we are saying higher temperatures require shorter processing times to achieve the same level of microbial kill. So, if you expose microbes to higher temperatures, that means you're going to expose them for a shorter period of time. But if you're having low temperatures, that means you're going to have to expose these microbes to a longer period of time to achieve a level of microbial kill that you desire. And we're saying this follows a logarithmic relationship. A slight increase in temperature can significantly reduce the time it needs to kill these microbes, and vice versa. If you reduce that amount of heat that you require, then this will significantly increase the time it is required to kill those particular microbes. I hope we are getting each other. For the batch processing, we're saying the entire product is heated as a type of processing. For the batch processing, we are saying the entire product is heated in a large vessel, like a batch soup simmering in a pot, a batch of soup simmering in a pot. And we are saying what are the advantages? The advantage is simpler equipment and more accessible to monitor the temperature. The disadvantage is a slower processing time, but also there could be avenues for uneven heating. Remember now, the saucepan is big or the container you're using is really big, and there are some places that would not get that optimum temperature that you require. And also the way the heat moves throughout the food product could not be evenly distributed. Okay, that is with the batch processing. Now, when we look at the continuous processing, we are saying here the product flows continuously through a heat exchanger, allowing faster and more efficient processing. This we talked about earlier on in the packaging, and we are saying think of a conveyor belt. Okay, that belt that sends things to the cashier. Okay, when you are in a supermarket and you just put something here, then it moves on that conveyor belt to the cashier. So when we are looking at this we are looking at it in irradiation, if I'm not to forget in one of the forms of drying and etc. I think it was under the drying or the packaging presentation, I should say. We are saying think of a conveyor belt with food passing through a heated chamber. Okay, and here one of the advantages is for faster processing time and more uniform heating. But the disadvantage of this conveyor belt or this continuous heating process, we are looking at a more complex use of equipment. Okay, and this will require precise flow rate and also a temperature control. You should have those thermostats and all those things that manage heat exchange and heat transfer. Okay, there are also different types of of equipment that are used for the continuous processing, like the plate heat exchangers. We are looking at these as the thin channels that allow that heat to be transferred between the product and the heating medium, but also the tubular heat exchangers. We are looking at the product flowing through tubes while hot liquid or steam hits the outside. All right, so heat processing methods one, we have the thermization, then we have the pasteurization method, the sterilization method, which we've seen in detail, but also we have the commercially sterile and also the blanching, where we're looking at exposing a particular food to very high temperatures for a very short period of time. Thermization, we are looking at a mild heat treatment that extends the shelf life slightly. Sorry. Okay, we were saying that the thermization, we are looking at a mild heat treatment that extends the shelf life slightly by reducing some of this vegetative bacteria, okay, or the alternate spore forming bacteria, but does not eliminate all pathogens. So, this, however, we might want it. We could opt to use it for those foods that have a shorter shelf life. Okay, and such as this prepackaged salad. Sorry, we expect to eat these foods, or we expect these foods to be consumed within 2 to 3 days maximum. Because even if we try as much as possible to prolong them, we can't do much with them. So that's where we'll do the mild heat treatment. For the pasteurization, we are saying this one is a common method of using low temperatures to kill the most harmful bacteria, but not the spores, as we will see. And we are saying this one significantly extends the shelf life of food while minimizing the quality changes. Okay, so we use temperatures that are less than 100 degrees Celsius, okay, or less than 212 degrees Fahrenheit to kill those harmful bacteria. I hope we remember this at the end of the day. When we are looking at pasteurization, we are looking at using lower temperatures to kill those most harmful bacteria, but not the spores. And also, we see that this will help us in extending the shelf life, but also will not do it as dramatically as the sterilization method, as we'll see. Examples of these products that would submit to this heat processing method of pasteurization, we have the milk, the beer, the fruit juices, also a minimal impact on food quality, yeah, is experienced when we're looking at the pasteurization method as a form of heat treatment. One of the kinds of pasteurization, we have the high temperature short time. Okay, that is one of the pasteurization. We are saying this heats milk to specific temperature for a short period of time, striking a balance between safety and quality. Then also we have the Thanos pre-pasteurization. We are saying here the product is sprayed into a mist, into a hot chamber for quick and continuous pasteurization. That is one, but also we have that high temperature and short time where we're looking at you subjecting the liquid, or if in this case we are looking at the milk to a specific temperature for a short period of time, striking a balance between the safety and also the quality of that food. So now let's shift gears and look at sterilization. So this one is a bit harsh, and we are saying it is a harsher treatment where we are looking at using those high temperatures to try as much as possible eliminate those microorganisms, including the spores that we've seen that cannot be affected by thermization and also pasteurization. We are saying this creates shelf-stable foods that can be stored at room temperature without storage. But however, when we looked at pasteurization, we saw that some of the foods that are submitted to that heat treatment method of pasteurization, we tend to use further methods such as refrigeration, and also for the blanching method, we tend to use refrigeration to prevent these foods from going bad and etc. We are saying it is ideal for for shelf stable foods like the canned goods, but its downside, we are saying that high heat can significantly impact the food quality in terms of the color, the flavor, the texture. Also, we are saying in container processing, the product is sealed in containers and then heated for sterilization, ensuring that the food will achieve its maximum shelf life. So for the commercially sterile, we are saying similar to the sterilization, but this will focus on removing those harmful pathogens, or the bacteria, or the microorganisms, and also those toxic forming microbes from the food. Okay, yeah. Also, we are saying this is usually used in the commercially processed foods, but also it maintains some food quality compared to the complete sterilization like we saw. For the blanching method, as we've been singing about it, we are looking at this pre-treatment of fruits and vegetables before freezing, drying, or the preservation method since it doesn't work alone. We are saying its primary function is inactivating these enzymes, okay, such as the peroxidase that can cause those undesirable changes, such as the browning, and also give us the off flavors when we are storing these foods. And also, the texture loss could happen during the storage. So, in an attempt to counteract that, that's when we employ the blanching method. So here in the blanching, we have different techniques that we usually call them methods. We have the steam blanching where we are looking at exposing a food to hot steam for a short period of time. But then we also have the hot water blanching where we are looking at briefly immersing a food in boiling water, still for a short period of time. Okay, so testing effectiveness of this method, we are looking at you being able to evaluate the blanching effectiveness when we are looking at the enzyme activity, the peroxidase enzyme activity, okay, using specific tests to monitor the changes in color or the changes in texture, okay, and primarily this is used for the fruits and vegetables, where we are saying that this involves a brief exposure of boiling water to deactivate those enzymes and also kill some surface bacteria, okay. Right. And we are saying that this blanching still, or this testing of the effectiveness helps preserve that color and also the texture for freezing and also other preservation methods once we are done with blanching. Blanching heat and quality, while higher heat kills the microbes, okay, this we have looked at it in the sterilization method. We are saying in blanching, however much the heat that we have subjected this food to will help us in eliminating those microbes and etc. But also this heat will change the color of the food. Okay, the heat will change the color of the food, but also it will also affect flavors. Okay, once you're subjecting this food to high heat, then we'll get that burnt taste, but also we'll get the loss of delicate flavors. Okay. Also, we are looking at still the sensory qualities of food, such as the texture, and also reduce the nutrient or the vitamin loss that could happen in there. But also, when blanching is done, we tend to look at thickening of soups and sauces, and this we are looking at it in reducing the readiness of those particular foods. So now let's look at thermodates, as we'll see that this is the heat required to kill the number of microbes that we'll be looking at. So this graph, actually, let me bring it down so that we can see the graph that talks about. So the thermodate, we'll see that in thermodates you have a decaf and all the d value, and also have the logarithmic depth. Okay, so in this value here, I hope you're getting this is our d value, and this is our d value. Hello, yes, I'm getting feedback from you. Can you please mute? Atta. Oh, our friend, we are going to hear your secrets if you don't mute. All right, let's proceed. We are saying that this d value here, what we call the death rate curve, we are saying this shows the time required to kill 90%, okay, of the specific microbe population at a given temperature. So the lower the d value, this indicates that the microbe is more straightforward to destroy with heat. Okay, but then the higher the d value, that means you're using a higher time. Okay, you're using a higher time to kill that bacteria. So that means the bacteria is less affected by the heat treatment. Okay, that is the d value. Then the logarithmic death. We are looking at this, the bacteria die progressively faster with more prolonged exposure to heat. For example, if you look at 90% of bacteria dying in the first minute, and also 90% of the remaining 10% die in the second minute, and so on. Or you could look at 40% dying, then 40% dying, then 10% dying, and 20%. We are looking at the progressive death of bacteria once we are looking at the logarithmic death. But for the death rate or the d value, we are looking at the number, okay, or the time that is required to kill 90% of a specific micropopulation at that given temperature. Okay, so now this gives it to us a bit. So this is our d value. Okay, the d value, we are looking at the number of time it takes for us to eliminate 90% of the food. Sorry, the number it takes for us to eliminate 90% of the bacteria. But also we are looking at the number here in, for example, to be able to kill 10,000, if we were to label this graph well and have this as being our first hour, second hour, third hour, and fourth hour, our d value, if we expect that 90% will die within this particular period of our third and fifth hour, then we tend to say that these 4 hours are what gives us the d value. But also, we are seeing that some cells, we will see that the vegetative cells die within this, okay? But also, the Clostridium botulinum will take some time to die. Remember, these are spores. The spores have a high tolerance to heat, but also we'll see that some that take a lot of time to die, such as some of thermophilic spores, these require longer exposures to heat so that they take so that to be able to be denatured and etc. So the thermodeath curves, the other TBT, we are saying this is the minimum time required to kill a specific population of microbes at a particular time. Don't confuse it with the d value. We were talking about the d value being the time that is required to kill 90% of that population of microbes that you're having present in a particular food product. So for the thermal death time, we are looking at this is the minimum time it takes to kill the required to kill this is the minimum time, sorry, required to kill a specific population of microbes at a particular temperature. So once the heat reaches that temperature, then we expect that all the microbes present be killed by that temperature. So thermodeath curves, as we have seen, we've seen the TDT, we've seen the D value, we've seen the logarithmic death, and etc. I hope you remember once that is asked. So for the thermodeath curve, we are saying spores. As for resistance, we are saying these are usually a dormant stage of some bacteria, and they are adapted. This is their mechanism of adapting to extreme heat conditions or to extreme environmental conditions. So these spores are in that dormant stage because of whatever environment mean. These are not going to become functional microorganisms. These are the things that are sometimes present in those foods that are canned or tinned foods, the Clostridium botulinum and etc. Also, I think is it botulinum or perfringens, one of the two, is spore forming. So special sterilization methods are needed to eliminate these spores. Remember, we saw that only the sterilization method where we are exposing the foods to high heat for a longer period of time, these are the only forms that help us in destroying those spores. But also we are saying after sterilization, retorting, ideally, no microorganisms should be present. However, strict processing and hygiene protocols need to be done to ensure that there will be no further contaminations happening after sterilization have been done. So when we look at microbial spoilage of this kind of foods, we are saying spoilage can occur if improper sterilization is done. For example, inadequate heating allows some resistant spores to survive, like we saw, but also the container defects. Okay, some of the containers people use will cause leaks or faulty seals that can introduce. I'm saying obviously those containers that have the leaks and seals, this can introduce at improper handling after sterilization, which can introduce microorganisms in food. Okay, what are the other factors that affect heat resistance? One, we have the species, like we had seen. So we are saying that different species or different types of microbes have varying inherent heat resistance. For example, the spores are much more resistant than the vegetative bacteria, or those that are non-resistant. Okay, or those the foods that are non-resistant, and we are saying this is because of their protective outer coat that they have. These spores have outer coat that will help them in being okay or in being more resistant to those high environmental conditions that they have. But for the growth stage, we are saying microbes in exponential growth phases actively dividing are more susceptible to heat than those that are in a stationary phase that are not actively dividing, or those that are at their death phase when they have reached their maturity and now they are dying off slowly. Okay, other factors affecting the heat resistance, we are looking at environmental conditions. Okay, so we are saying some factors due to the food itself that will influence the heat resistance. Not only the microbes, but also the sorry, not only the microbes, but also we are looking at the environmental conditions of the different foods. Things to do with the pH. Okay? Microbes generally prefer pH range for their growth. Okay, so extremes of acidity or alkalinity can make them more susceptible to heat. But also, we are looking at the water activity. We are saying foods available water activity affects microbial growth and also heat resistance. The lower water activity or the dry the environment, this can increase heat resistance. If the foods, if the organisms can tolerate that, then they can still tolerate high heat. Presence of solids, things to do with the sugars and the salt, this can draw it out of the microbial cells, reducing their water activity and increasing their heat resistance at the end of the day. Factors affecting heat resistance for the foods such as the fats and oils, this can provide protective barrier for some microbes, making them more heat resistant. but also we are saying presence of all those other organisms. For example, the vegetative organisms are there, the vegetative bacteria, but also the thermophilic bacteria are present, also the spore-forming bacteria are present. So all this competition happening between these different microbial populations can influence their heat resistance, where we are looking at survival for the fittest. Okay, so now we've looked at the heat treatments, we have looked at the UHT, we've looked at sterilization, we've looked at pasteurization, commercial sterilization, we've looked at blanching, we've looked at thermization, their indications, their contraindications, their challenges, and etc. So now let's shift and look at the high pressure processing. High pressure processing, also known as high hydrostatic pressure processing, is a widely accepted minimally processed technique, okay, where we are looking at this in activating those microorganisms during food safety without compromising the food quality of that particular food. So, what happens when we are exposing these microorganisms to high pressure? So, one of them is susceptibility of the different microbes. For the bacterial spores, we are saying these are more resistant to this high pressure processing, okay, due to their protective outer coats, the spores and etc. But for the vegetative bacteria, those without spores, these are more susceptible compared to the spores, but also their resistance can vary depending on the species, the growth stage. We talked of those in the lag phase, we talked of those that are dividing, but also those that are dying at the end of the day. But also, we are saying the heats, the yeast and molds, these are generally less resistant bacteria, although some strains of these bacteria may be more resistant to this heat, to this high pressure processing. So, viruses typically are inactivated by this pressure processing, but effectiveness can depend still on the specific strain or variant of the high pressure processing effectiveness still continued. One, we are looking at the strain variation or the variant, like I had said, and we are saying different strains within the same species can have a varying high pressure processing resistance. Okay, yeah, but also at the growth stage that we had talked about, the pressure and duration of exposure to this high pressure processing. The higher the pressure and longer exposure sometimes enhances microbial inactivation. But if you reduce the amount of pressure and also reduce the time of exposure, then we tend to say that you will not achieve the maximum results out of this. Pressure and duration that we had looked at, but for the temperature, we are saying combining this high pressure processing with moderate temperatures will increase its effectiveness. So it's not a standalone method. It could be coupled with other methods of microbial, what should I call it, microbial death, methods that help us in eliminating those microbes, I should say, such as the heat treatment. Factors affecting this effectiveness, we also, this high pressure processing effectiveness, we are also looking at the food composition, okay? And we are saying the presence of solids, the fats, or specific food components can influence this resistance of the high pressure processing. Things to do with combination treatments, where we are looking at combining this high pressure processing with other forms of preservation can give us synergistic effects. When we talk of synergies, we are talking about you're not essentially getting every advantage or you're not getting everything from that particular processing method, but you're getting them from not from more than one method of preservation. Okay, impact on food quality, we are saying ingredient functionality. Uh, for the foods that are subjected to high pressure processing, we are saying this might affect the functionality of some ingredients, like the functionality of protein in meats. And for the enzyme activity, we are like we had said, this will help in inactivating those enzymes that cause deterioration of foods, but also when they do this, they will increase the shelf life of foods by delaying down that, or by slowing the spoilage and reactions. that are going to be present once these foods are left at room temperature. However, this might also affect that desirable enzymatic process that could be required for the ripening of cheese and other processes that could be desirable. So for the foaming and emulsification, remember when we're talking about foaming and also emulsification, we're trying as much as possible to mix these immiscible liquids such as the water and oil. So in this high pressure processing, we are saying this can disrupt the protein structures, impacting some foods forming and also emulsifying properties. Okay, for the gelation, or what you could call the gel formation, we are saying this high pressure processing might influence the gel formation in some food products. But also, we are saying while this high pressure processing preserves the flavor and texture better than the traditional heating process, there are some changes that could be experienced in the mouthfeel and also in the color of these foods that are treated using the high pressure processing. So, colleagues, that brings us to the end of our presentation. We have been looking at the heat. We are looking at the use of heat in production